Now let's first calculate the expected time for each activity. Based on the formula provided, a plus 4m plus b over 6, we are able to get the expected duration for all the activities. For activity A, we've got 10, and activity B, 20, 30, 40, 10, 28, 20, 10, 24, 12, and 10 for all the activities. Apart from getting expected duration, we also like to estimate the variance of each activity, since we have 3 different values. And from the point of statistics, we always like to get the mean. We would like to get the variance. So we are going to use the duration values to get a variance. So the variance is estimated based on the difference between the pessimistic and optimistic over 6 and take the square. And the relationship between variance and standard deviation is the variance equals the standard deviation squared. And so that's the equation from here. Just be careful, that is b minus a over 6, and then for the entire value just take the square. It's not a b over a, take the square, then over 6. Just be careful. And then based on this formula, we're able to get the variance for each activity's duration as follows: 0, 0.44, 44.44, 177.78, 2.78, 75.11, 5.44, and 0.44, 21.78, 0.11, and 4.0. So that's the variance. Based on the expected time and variance, now we are going to calculate the schedule, which is the PERT schedule. First, let's just fill in all the expected duration underneath the activity. Besides, we are also going to get the variance. Write it down like this. So underneath the error, we're going to write down our duration slash the variance for each activity. Ten, 0, 40, 177.78, 20.44, 30, 44.44, 24, 21.78, 12.11, 28, 75.11, 20, 5.44, E 10, 2.78, 10.44, the last one 10.4.0. all right, so now first let's just work on the expected duration, and instead of using those pessimistic, optimistic, and most likely, we're just going to use the expected time, and we're going to do a forward pass and backward pass by using this duration list over here. The calculation process is exactly the same as CPM, regular CPM calculation activity on error diagram. 0 and 10, 30, this is 50, 50, and this is 30 plus 30, 60. We are going to get the max, 60, and 50 plus 10, 60, and 28 plus 0, that's 28. We are going to get the max, which is 60 right over here, and 84. Then this one is going to be 96, 70, and we also need to point out this one, which is 68, which is 38. and then we are going to pick the max out of those three paths, and we end up having 96. Last one is 106, and we are going to do a backward path calculation. 106, 96, 84, and 86. This is 76, and this is 60. And then coming backward, we have to get the minimum, which is 60 minus this is 50. Oh, sorry about that. This is 86 minus 76, 60 minus 0, 60, and we're going to get 60. And this is 30, 60, and coming backward, we have to get the minimum, so we ended up having 10. That's the minimum, and that's 0. Based on that, we are able to calculate the total float, free float, and we're now going to write down, and we end up having a created path A, B, C, I, J, and K. That's our critical path. Those are critical activities. And next, we're going to calculate the variance, but first let's just stop here.